Good morning, everyone. Today, I'll be going through an introductory class on organic chemistry because before we go into stereochemistry, it is very important that you should understand how to write different structures in organic chemistry because that is very important while we are discussing in the stereochemistry. So let me start with a brief idea which you might have already studied, but still I would like it to be done because many of you do not know how to write properly the structures in organic chemistry. So organic chemistry, as you can see, I've written down here, is basically composed of carbon compounds. Organic chemistry is composed of carbon compounds. And then mostly they are termed as hydrocarbons. Why? Because these compounds contain carbon and hydrogen in these molecules. Apart from that, you will find certain other elements like nitrogen, oxygen, and sulfur. So if you classify different types of organic compound that you find in organic chemistry, you can classify them as alkenes, alkenes, alkynes, and aromatic compounds. Apart from that, there are many other classifications, but most of the time you will be finding these kind of compounds. Okay. So let me move on further. Before I move on further, I would like to clarify here that carbon can only show 4 valencies. That means you can attach only 4 bonds to carbon. Never make more than 4 bonds to carbon and never make less than 4 bonds to carbon. This you have to keep it as a Bible rule before we go into further in writing the structure of the organic compounds. So this you keep in mind, carbon always has 4 bonds. It cannot have more, it cannot have less. So keep this in mind, and with this thing, we are going to write the structures of these compounds. Starting with alkanes. Alkanes have a general formula of CnH2n plus 2. Okay, now N can have values from 1, 2, 3, and so on. So let me write the simplest one. So when N is 1, the formula would be CH4. When N is 2, it would be C what? C2H6. When N is 3, C3H what? 3 2s are 6, 8. C3H8. Now how do you write? So these are very condensed formula. These are called condensed formula. Okay, now how do you write the full structure of these compounds? For that, if you see, if this is the simplest one, right? So carbon can have only how many valencies? 4 valencies, and these are 4 valencies are attached with the hydrogen. Now here, how many carbons are there? 2 carbons are there. So you have C, I have C, and then 1, 2, 3, one bond is already forming into the carbon, and rest is hydrogens attached. Hydrogen are monovalent atom. They can only form one bond. Similarly, you have these. So C2H6 atom. So condensed formula is this, and this is the expanded chemical structure. Expanded structure. Okay, so you should be able to draw now. You understood what do you mean by this. Okay, let's move on further to alkenes. So if you look into alkenes, alkenes have a general formula of CnH2n. CnH2n. Now what does this mean? So simplest would be C2H4 C3H what? 3 2s are 3 2s are 6. Now here, did you notice one important thing? That alkenes, the simplest one is C2. But in alkenes, the simplest one was 1 carbon atom. The simplest one in alkene is C2H4. Now how do you write? And these are saturated. Alkenes are saturated. However, alkenes are unsaturated. So both alkenes and alkynes are unsaturated molecules. So whenever I say that these compounds are unsaturated, that means it contains multiple bonds. Multiple bonds means something like double bond or triple bond. These kinds of bonds, when they are present, we say those compounds are unsaturated. When they are fully saturated, there is no multiple bond, there is no double bond, there is no triple bond, it's all single bond that is formed in this compound. Now, how do you write the structure of this compound? So C2H4 would be two carbon atoms, and you have multiple bonds that is formed with the carbon atom, and then so two bonds of if we consider this carbon, two bonds are already formed, so remaining only two bonds are possible. This carbon also, two bonds are already formed, so you can have only two more bonds. So those bonds are attached with hydrogen. Another important thing that you have to remember is that the multiple bonds are formed between the carbon atoms and never with the carbon and hydrogen. Hydrogen can never show more than one bond to another element. So always remember this. So don't draw multiple bonds like this. Okay. So never this is right. You can have multiple bonds only in between the carbon atom. That is the important property of the carbon atom, that itself gives this organic chemistry, it's different compounds. So how do you write the second carbon? So you have one double bond, so three carbon atoms are there. So you will attach something like this. You can draw a double bond here, or you can draw double bond here, wherever you want to, but only one double bond. So now if I write the expanded structure, this carbon atom has only one bond, so it will have remaining how many bonds? There would be three bonds left, and obviously since there are no other atoms, it would be definitely what? Hydrogen atoms. In the second center carbon, you have three bonds already formed, so it has only one bond that is possible, so you will write hydrogen there. And then this carbon again can form two bonds, so you have the structure. So it is C3H 1, 2, 3, 4, 5, 6. So H6 formula. So this is how you write the structure for your multiple bonds. This you should keep it in mind always. This is for double bonds. So alkenes are basically compounds having double bonds. Okay. Now let's look into what is alkynes. Now alkynes are basically compounds which have triple bond, and they have a general formula CnH to N minus 2. Okay, so it would be C2. Again, the simplest one is with the two carbon atom. So C2H, 2 2s are 4, minus 2, 2. Okay, similarly, next one would be C3H 2N. So 2 3s are 6 minus 2, 4. C3H4. So these are the simplest one. Now remember how to write the structure. So two carbon atoms. Definitely you will write two carbon atoms. I told now these are triple bond compounds. So you will have three bonds between them. Okay. So once this carbon has formed three bonds, it will have only one bond left behind. Then this will have only one bond. So this is the structure of your simplest alkyne. Then this one you can draw very easily now. So three carbons in a line, you will have one triple bond and one single bond. So when I say alkyne, it has one triple bond. Now, if you see this carbon, it has 1, 2, 3, 4, 1, 2, 3, and 1, 4, 1, 2, 3, only one more, because this has already three bonds. So you will attach hydrogens there. So you have 1, 2, 3, 4, 5. Right? So did I do some mistake? Yeah, definitely I did some mistake, because it can have only 1, 2, 3, 4. Okay, this has already formed 4 bonds. So 1, 2, 3, 4. Got it? I did a mistake here because this is triple bond, right? So 1, 2, 3, and 4. This carbon has already 4 bonds. You don't need to attach a hydrogen. Okay? And in this case, 1, 2, 3, one more bond is required. So you attached a hydrogen. So this is the formula. Now, please try to add more number of carbon atoms and try to draw their structures. I'll talk about the name of these compounds. So if you have one carbon atom, okay, probably this is not doing pretty good. If you have one carbon atom, then the name should be something like methane. Okay, now if it is two carbon atom, it should be ethane. Now ane means whenever you are alkene, the suffix should be ane. Suffix means that coming at the end of the name. Now this would be propane. Now I would like you to look for the other higher carbon atoms. Now in this case, when it is alkene, now what happens to the alkene? Now alkene, the simplest is with two carbon atom. Now two carbon atom, the name should be having a prefix as ether. So it would be ene. Now it won't come. It will be ene. Alkene means ene. So ethene. So this similarly would be propene. Okay, so in this case you can, since there are more than one carbon atom, you will number them. So it would be 1 propene. Okay, similarly this would be now called as E, because two carbon atom, ine, because it's alkyne, so suffix would be ine, ethyne. This would be 1 propyne. Okay, so this is how you write these particular compounds, and please practice them, because you should definitely practice how to draw the structures and try to write their names, because when we go into it, it would be a little bit more faster. Okay, so I would like you to really be understanding how to draw the structure. Now I just will give you a hint of what these aromatic compounds are. Aromatic compounds are basically compounds containing benzene molecules. So benzenes are basically 6 carbon atom cyclohexene with the alternating double bond. This is the structure of benzene. Now each carbon atom will be having 1 hydrogen atom each. Just remember this particular compound. This is the simplest aromatic compound, that is benzene. Now how you don't need to by heart these structures, because once you draw the cyclohexene structure, draw the alternate double bonds, and then how many hydrogens is very easily calculable, because this vertex is a carbon atom. So in organic chemistry, whenever there is a vertex coming like this, that you have to understand that the vertex is denoting to carbon atom. So this carbon atom has how many? It can only form 4 bonds. So 1, 2, 3. So it has only one more bond possible. So that would be attached to hydrogen. Its condensed formula is C6H6. So please revise these structures, try to draw them and be comfortable with this. You will be learning in functional group, various other functional groups. Try to draw them properly, okay? Because in stereochemistry, we are going to discuss this is the 2-dimensional structures that you are writing here. The expanded structure is also 2-dimensional. Now, in that, we will be talking about the 3-dimensional aspect of these molecules. Okay, so I hope I have briefly made you understand how to draw the structures. You practice them and be very much efficient in that. I would really want you to be efficient, because this drawing structures is very important in organic chemistry. Once you are mastered in that, and any topic in organic chemistry would be so simple for you. Okay, so just keep drawing these structures, try to find out the names and all those things, just go through it. Okay, so let's discuss further in this, get into the stereochemistry and isomerism in the next session. Thank you so much for being patient. Thank you very much.